finally we reach the end of this course of lecturing. Well, from the very beginning, we introduced the overview, from overview of system analysis and design. Then we discussed the methodology. So methodology is quite complex because we'll have different kinds of methodology. Depends on the system that we're going to design. So roughly, probably we can divide it into structure, unstructured, and agile. We also describe structure, or what structure is, then unstructured, then agile, and we also know that if we design a system, we might combine a couple methodology together, right? Part of that we will use structure probably, right? But structure combined with other, like prototyping, right? And we also learned that there are some concern. If we concerned a lot about the risk management, then we might apply different kinds of methodology, right? And that the way discussed in Kong's, right? Kong's textbook. So since we have learned so many methodology, right? So they help you, to think flexibly, right? So maybe you think that's we're going to take a bit from the government, but not just use structured methodology. You might use others, right? Except for that, right? You probably can't use your own, right? So we learned the formal process because that's education, right? The more you learn, the more flexibility that's you might gain, right? And after that, we focus on object-oriented concepts, right? OOP, right? Object-oriented programming, because it is the train, right? So in chapter 9, we will see a table of comparison, different object persistence that we're going to choose. It talk about object-oriented database is a maturing, field like that. But I said that no. And it says professional is hard to find. It's also not correct, right? Because since so many years that students learned a lot of object-oriented concepts, right? And we talk from very basic object concepts, all right? Introduce attributes, matter, and communication, all right? And then we learned how to draw by using UML, right? In terms of different kinds of diagram. Could be static or dynamic, right? The most often used, that is class diagram and sequence diagram, right? But we learn the requirements, right? So we are not going just from sequence diagram. We need to know how many functions that we're going to have or design. Function usually it means function requirements, all right? But this chapter also, the later parts only a little bit, so let's talk about non-functional requirements. But remember that I said that functional requirement is the basic, right? They will not help you gain the market share because function is the basic, right? If you want to design a banking system, you need to have the necessary function, of course. So each function is a use case, right? And we are going to describe the use case, right, by using texture, right? Texture description, right? There's a dialogue, or we will use other diagram. Like you wanted to understand the flow, then you know that activity diagram, right, may help you understand the flow. A sequence diagram helps us to understand the function, right? The and how they communicate by using method, right? So method, so requester and receiver, probably more than one receiver. So roughly, you know how to draw that, right? Of course, a class diagram, it gives us the whole picture of whether it is static, right? And then, well, a very difficult part that you confuse about state machine, right? State machine usually you will misuse that because you thought it is similar to the process, the activity flow, but actually it's not, all right? But state machine is also very often used, right? Because you wanted to know the status change, all right? Then so we'll come to the design. We said that, well, planning, analysis, design, implementation, right? Then related to two issues, right? We need to have the rights requirements, right? Right requirements. We need to know what our client needs, right? So the right requirements are do the right thing the first time, right? So do the right thing, that's quite important. So if we don't have the rights requirements, no matter how rights we follow that, it's totally wrong, right? So do the right thing and do the thing right. So that's regarding, you know, the validation and verification, right? So VMV issue. So analysis, that's very, very important, right? Hopefully we have the right beginnings until the ends. Okay, and we analyze it by using a lot of diagram. Then come to design, right? Of course, we will reverse, right? So to fix it, because some of the function we might hold on, or some of that, right? For any reason, we wanted to change that. If we cannot change that, then there will be a problem. Unless we're quite sure that we are familiar with the system, we just wanted to revise a little bit of that, then we are not going to from the very beginning, right? Fix part of that. Chapter 7 or 8, right? Because different version. Then we talk about design. Come to design, then it become very difficult, right? Because know the what, that will be easier, right? Know the why, right? Okay, know the why. It's very important. Know the what, right? Unless you miss something, right? We feel that. But know the why is very, very important. Then we know the what, but we know the how. It's very difficult, all right? So that's why we spend a lot of time in digging out many issues of data and method design. then how to manage that? So you might use the concept, right? Object-oriented. Use the concepts and apply to different database. Different databases, right? So in chapter 9, from file processing, right? We also call it, that's the way to store, okay? Store your data, right? So object persistence means that the data we are going to store for later use, all right? Not for temporary usage. Right? Some transaction file is for temporary, which is going to store it. We create a file quite often because it is very easy to create it, right? Very easy. And file, don't think it's file is useless. No, it's very useful, but need to along with programming, right? So with file creation, then probably we don't care about data duplicacy, right? Data consistency, because when we change a record, right, the others we may neglect it, all right, but we know that they will cause data inconsistency, right? That's why we need a good method to manage that. So it comes to database management, right? From file processing, most often we will think about relational database. So relational database, so it's one. So not one thing will stand alone. They're related to others. So related database connects other data, all right, by using key, right? So we learned many kinds of keys. One key to identify a record, right, uniquely, right? We use primary key because primary. We also talk about what could be a primary key, all right? You might have different options. From the options, we choose the best one, right? Then you should know how to choose that among all these candidates. It connects with other data, all right, and we call this table. Right? Every table has its unique key. By using unique key, this primary key become other tables foreign key. So by using that, we connect. All right, that's different concepts from object-oriented. All right, object-oriented is going to combine data. All right, we talk about an attribute or field or whatever. All right, the object combines the data and method. All right, encapsulates. So encapsulated. Say we don't want to reveal to others unless you ask, all right, or unless the object set it public, or provide for subclass to use it, all right. So different visibility. So you should also know visibility of the attributes. So from file processing to relational database, we can see that you see often ERT, entity relation diagram, the concepts, right? So from ERT, this just like our object concepts, the class diagram. So ERD, from ERD, then we can convert it to relational database, right? E means entity. We also learn DFD, right, to understand the process, right? So process oriented. So from the process, we talk about all the rule, right? Then it's going to store the data, right? And two represents the entity relationship from the diagram. So I said that from ERD, then it's very easy to transfer it, convert it to relational database. Right. So roughly relational database by using key. Then it solves the problems of multi-value, right? Multi-value and to keep data consistency. To do that, you need to understand normalization, right? So normalizations then help us to make sure that data is consistent. We only change the main table, right? So this, then other table, automatically, because we have foreign key, right? That is very easy to manage that. And also solve the problems of null cell, because we have no idea how many multiple column or fields we're going to have, right? We solve the problems of that and keep data consistent. And also we can access a record from different table, right? After we normalize it, but also raise a problem, all right? Because we need to join. So join takes time, right? So it takes time to process that, the join. Okay. And times pass, so object concepts become very popular, the object oriented. So we combine data and process, into one. But what about the relational database? What about the file processing? Right. Relational database help us solve the problem, right? Just I mentioned that. But also it's a problem, right? Then we come to object concepts by using object-oriented database, but we still need to consider the existing databases, relational database. So this chapter helps us that then we should know how to map, right? Conduct mapping. So mapping from relational database, right, to object-oriented. But in between, for instance, that is something that can help us, just like a bridge, all right? It's in between. So have each ends relational, right? Feature and object, right? So comes up object relational database. Relational database, even though it is, useful, but it cannot handle complex data formats. All right. So that is very big weakness, right? But our object-oriented can handle, simple and complex, even while processing, can handle simple and complex. And today we'll also talk about the other object persistence. It's not SQL. All right. No SQL. because data, you know, has different formats, then that's beyond object-oriented or a relational database, right? It's quite flexible, and we create data quite often. So we are not going to fix to very rigid, particularly the relational database. It's the fixed field, right? But no SQL, not that, right? And even though we know how to map that, or by using tour, right? So tour is object relational, mapping. So you're going to see ORM, but ORM cannot solve it totally. You still need to learn ORM. It's not a plug and play tool that easy. You still need to learn it and fix it. All right. It helps us a lot, for sure. But ORM, no, you cannot trust it totally. So the mapping, no, you need to do it, but also you need to fix it. And when we come to the varied kinds of data, right? Then how do we deal with that? So today we will also, the last issue is about NoSQL, right? How can we convert, right, from relational database, object-oriented to NoSQL? Since a lot of data, it's a big company, like Facebook or Meta, right? They don't use relational database. Well, no, because we have a lot of data, right, to manage that. And Amazon, right? Amazon it's a, we use a name, right? Key. We have a key. Then it's corresponding value. Particularly is the shopping, right? There's a lot of data, right? What they care, just the piece of that. And they don't care about data consistency because it doesn't need to. So for example, price always change, right? That time, price, you are not going to change everything, right? You gotta keep the price as it was, right? So that price, and now we change, raise the price, or it's going to lower the price. Just reflect the facts, right? And we have social media, right? So social media, how to manage social media? How do we know that it's a store, right? Has a lot of fans. How many fans follow the store? And what about their relationship, right? So like this, then or we wanted to manage the special data or geographical data. We wanted to know that from one location, right? So when we describe the flights, right? Example, wanted to purchase tickets, but what about we wanted to order even transportation, right? We need to know from one location to other location, the distance, and the vehicle, they move. How long will reach, right? The destination. Like that. A lot of these kinds of dynamic data. How can we manage that? We are not going to use traditional way. do it, right? So it's very, very important for the data management layer, as like most often you are going to practice smaller or even probably medium size database. Then what kind of database you're going to choose? So all these issues are very important. So that is how, right? So how to, even though you know it, then how to deal with that. That is difficult. So all that, see in chapter 9, right? So chapter 9 is teach you how, right? And the 8 also, right? So we are not just tell you that just do it, right? We got to know the reason, right? That's what education should be, right? So you can go to crime school, right? Crime school to learn how to program, how to program, but education is help you how to learn, right? So education will not give you, just this, follow this, but it should tell you the underlying reason, right? So you become a person, to know how to think, right? So that is, they will not teach you, right, in crime school. So it should be different. So the formal education is not a training, training field, right? And not just tell you that follow this, or we should tell you the underlines, and of course you need to practice. Right? That is quite different. Right? That's why we spend a lot of time for one semester, for a course. So many courses should have is underline. That's quite important, right? That's make a difference from the formal education and the crime school. All right, you can go to crime school to learn some skill quickly, right? But in the formal education, that shouldn't, right? Shouldn't like that, like crime school, quick learn, right? Not that. Okay, so yeah, let's review part of it. Let's see. From object-oriented to object-oriented, skip that part because quite nature from object to object, right? So you will see that from object to object relational, but object to object also, because our problem domain we presume is object-oriented, right? So last time we talked about from our problem domain. So remember, it's our problem domain because we teach object concepts, right? So you gotta presume it's object concepts. So whenever from problem domain, that's object concepts to object oriented, what we care is that inheritance, multiple inheritance, because not just all the language, not just no, will restrict inheritance, right? Some of that are allowed to have multiple inheritance, right? But it just tell you that multiple inheritance, when we have multiple inheritance, right? For some language, it's no problem to that, right? For different language, it's only allowed to have single inheritance. Then you know how to conduct a mapping, right? So the only way we talk about this, right, and associative class like that. Then for problem domain to mm, object relational, right? It's in between object oriented and relational, object relational, right? Then I will not repeat some part of that, like the difference between object relational and object oriented. So here, what you're going to see, we have the problem domain. So presume we have four class, right? Classes. And now you can see object oriented, object relational. So object oriented and relational. Object relational database management. Here, I use the concept of relational, use table. Right. If there's object oriented, then we use class. Right. Table and class. Then patient. So we presume participants, right? Participants could be multiple, and actually it has multiple subclasses. But one of it is patient. One of it, right? Patient. So this one, patient, depends on patient, right? And could have others. So the rule one tells us that if appearance, a superclass, right, is more than one subclasses, then you should conduct a mapping. Every concrete classes, okay, so every concrete. So we have four classes if there's a concrete. If this is a concrete, then everything, we need to have a mapping. So we map four concrete classes. So if this is abstract, right? If this is abstract, then it is not just one, right? We have a couple of beds, but you cannot see this. We might have others, right? Doctor, employee, right? Then participants. So if participant, there's abstract. We also conduct the mapping, right? So it could be a concrete class, it could be an abstract class. Alright, and you will see here, since that's one, and this is one, we will need to describe that. Right, so one participant is one subclass, and name is patient, and we might have other subclass. So here, from this part, Bridger, round the multiplicity tell me that participant is an abstract class or concrete. Round the multiplicity, how can we know it's a concrete or abstract?
I think it is a concrete class.
It's a concrete class.
It is one participant table, one participant to one patient. It is one to one.
Okay. Shan, what do you think? Yes?
I think we cannot know is abstract or concrete, so we should just think is abstracts for some issues. So we cannot sure. So
Cannot
we
sure.
always think is abstract.
Always think it's an abstract.
Yes. I think.
Always, but you think you're not sure. You're not sure, but always. What do you mean? Sure, not sure.
Not sure.
So you're not sure. You think it's concrete. All right. Is any of you think it's the third option? So not sure, concrete. Then how many of you think it could be abstract? No one. Kevin?
I think it's abstract because it's 1.1 on parent and 1.1 in the child. And the child, if it is abstract, and it must be 1.1. If it is concrete, it will 0.1.
Correct. That is abstract. Right. It's abstract. So participants is an abstract class here because we can see that it's one. If it's concrete, you 0, 1. Concrete, right? But it's abstract. So you gotta determine is abstract or concrete. And then we can see that the monoprosity, right? So about the feature, conduct the mapping, right? And here, patient again, right? So patient. That is how many attributes of patient? I asked that the last time.
Seven.
7.
Yes.
7, right? And here you can see, so it's a 7 because would you tell me that? What is it 7?
Amount.
Amount? Yeah? Amount? It's a 7. And tell me the 7. Insurance?
Yes.
Insurance carrier?
Yes.
And
And make appointment. No. Last name, first name, address, phone, birthday.
and how many?
7.
7. So 1, 1, 2, 3, 4, 5, 6, 7, and 8. Why does it have 7? Heady. Right. Then so we cover that, right? Conduct the mapping here as table, right? Would you explain the field inside that? Explain that. We just said that patient has 8 attributes, right? Then we conduct the mapping. Here we have a table, patient. Would you explain that? Anyone can explain. Explains the field. Anyone can explain that. Somebody can explain that. It could be possible. Carol, explain that? Can you? Do you understand that? You don't know the question or you don't understand.
Can I check the question again? Because I'm a little no understand the question.
The patient has
Yes.
8 attributes.
Yes.
We conduct a mapping.
Mm.
So would you explain this part?
Explain the patient table.
Of course.
Okay.
Does anyone wanted to answer? That took much time. Somebody knows that? Kevin, do you understand that?
Maybe I can try. And I think the patient table, he map the patient on the right side, the amount and insurance carrier, and the person is superclass. The symptom is the appointment because he in the right side he linked to the appointment class and he scheduled with it, and the symptom because he suffer with some symptoms, so he put it in the attribute, and the primary insurance carrier is the reflex line.
Mm-hmm. Okay. Yeah, and here, because the textbook has lots of typo, remember, right? The typo. So here you can see. So patient, at least patient need to have 8 attributes. You can feel, right? So, okay, see that. How does the patient knows participants? Should have 8, right? you presume the patient has 8 attributes. Whenever we convert it, and tell me that where is the age? When we convert participants,
the age，它应该算是衍生属性。It is from the birthdays to count the age, so you will not map on the person table.
then how can we deal with that? That means a table will not have derived attributes,
Yes.
but we still need it. Yeah, there is a question. If you know that, raise your hand. And for the patient, right? Kevin, you see that itself, this one amount not package from the parents, but care amount the insurance carrier, right? It is a lowercase. And here, what do you think? Is it lower or it's uppercase? Oh.
Lowercase.
Lowercase. So it's not correct. And it's not correct. Right. So obviously everybody should know it. All right. No doubt. So if you have questions that why is it uppercase, that means you don't understand, right? So it should be lower, right? So that's not correct. It's a typo, right? Insurance carrier. It's multiple value, right? So here, it's going to see that participants is an extra class because it's referred to the multiplicity, right? Extra class, so we got to have one, right? Otherwise, it cannot instantiate itself. And then patient should have everything. So our problem domain from parents, but things, table, here, object relational. So it has no inheritance concepts. It means we have the parents, all right? Not parents, all right? Parents from problem domain, but it's no parents and children. So we're going to take, right? Become relationship. So participants was the superclass, but now become association. So here we should put participants inside here. And you can see that 1, 2, 3. So all 3 it's going to put inside. You need to read it, right? Not until I told you that's what education, you need to learn how to learn it. Right, that depends on lecturing. It's not correct. And here we have primary insurance carrier. All right, so it says role. Primary insurance carrier.